This is my lab report for Lab 2, Motion of a Falling Object. In this lab, we were asked to observe the motion of a falling object that was dropped from rest. To do that, I dropped a basketball from a second-story balcony and recorded the motion on video. Then I analyzed that video using the tracker software. And then I created two models using the VIDLE program and compared my models with my experimental data. As you can see on the graph on the screen, my experimental data, my model, and my model with drag force all were very close together in their measurements. You can see that there were several physics principles at work here. The first of which, the fact that all objects have a constant acceleration in the absence of air resistance or other resistance, and that air resistance is influenced by the speed of the object as well as the area of it. So using a basketball, there's a little bit larger area that can affect the acceleration. You can also see, and can tell this from my graph, that the distance that the object travels is proportional to the square of the time. For these objects, they will reach a terminal velocity, which is the maximum velocity that can be reached when the force of air resistance reaches a magnitude equal to the force of gravity. Now, when I was creating my models for this, as I said, I used the VIDLE program and had to initialize the program to run as the model that I wanted to use. So a few things that I had to do with that is I had to add in the mass of my object. So in this case, I looked up the mass of a standard basketball and was able to put that in kilograms. For the first model, the only thing that we took into account was the weight force on the system. So that information was added in. And then for the second model, not only was the weight force taken into account, but so was the drag force. So that information also had to be added to the program. In addition to adding that, I did have to double check that my time step was a very small one, and also had to, for the second model, add the proportionality constant for the magnitude of drag force, which was at 0 for the first model. I changed that to be 0.1 for this model. Now, in terms of looking at my experimental data versus my two models, as I said before, you can see that they are very close together, and you can see that there's not really much difference at all in the results from adding drag into the model. In terms of what does this mean with terminal velocity, yes, this object did reach terminal velocity. Speed increased the force of until the force of air resistance balanced out the force of gravity, and then the object reached its terminal velocity. Now, if I had thrown this object downward rather than just simply dropping it, that would change my terminal velocity. The object would still reach it, but because speed would be faster initially because of the force that I was applying to it, that would change the terminal velocity. We can also see Newton's second law at work once again here with our net force being equal to the mass times the acceleration. So again, you can see that my experimental data, both of my models, very closely match one another, and that the results for this lab illustrate the how a falling object would move when simply dropped from rest. Thank you.